All right, so welcome back. This is Unit 5.1. We're going to start off the new semester with studying gases. This is pages 474 through 499 in your textbook that you need to read. And in your study guide, that's going to be pages 199 to 213. Well, first of all, I need you to write down these 6 statements. This is what's called the kinetic molecular theory. And these 6 statements describe how gases act. Okay, and we're going to be talking more about these different statements in the kinetic molecular theory as we go through this section on gases. First of all, for 5.1, let's talk about the units that we're going to use for gases. In these gas problems that we're going to be doing, there are 5 different units that we're going to have, so we need to make sure that we know what units we need to use for our problems. So first of all, volume. We do measure volume in gases, and volume needs to be measured in liters. Liters. Okay, so if you have a problem that has milliliters or centiliters or some other form of liters, then you need to convert that over to liters. So for example here, 150 milliliters converted to liters. Remember, on our conversions, we're going to take our given, we're going to put it over 1, okay? And then we are going to use our questions that we have in our folder. All right, so the very first question when we're doing a conversion is, what unit do we have that we want to get rid of? The answer to that is milliliters. We want to get rid of milliliters. So where do we put it in our conversion to get rid of it? Okay, and it's crisscross, catty-cornered, or in this case, it's going to be on the bottom. All right, next question, what are we converting this to? What unit? Okay, so the answer to that is liters. Do we have a conversion factor that takes us from milliliters to liters? The answer to that question is yes. We have 1,000 milliliters is equal to 1 liter. All right, so remember, conversion factors are things that are equal, equalities. So since there is a conversion factor for this, we can go ahead and put liters on top. Now we're going to fill in our numbers. 1,000 milliliters is equal to 1 liter. Okay, our next step is cancel what you can cancel, which is the milliliters, because remember, what's on top of this conversion cancels what's on bottom. So are we finished? Well, do we have the unit that we want? The answer is yes. So the problem here is 150 liters divided by 1,000. So that's going to be equal to 0.150 liters. Okay, so remember, that's how we do our conversions. So all volumes must be in liters. Okay, next, temperature. There is temperature factors that we have to consider when we're talking about gases. And for gases, the temperature unit we're going to be working with is Kelvin. Okay, in the Kelvin scale, there is an absolute 0. The very lowest that you can go on the Kelvin scale is absolute 0. And then upwards, the highest temperature, where there really is no highest temperature on the Kelvin scale. So you're going to, in your problems in this unit, you're going to see standard, the words standard temperature. Now, we've seen that before as STP. When we're talking about problems in the past in chemistry so far, where we're using gases in the problem, it'll say this gas is at STP. That means standard temperature or pressure. And I told you up to this point, just ignore that. It's not going to figure into the problem. Well, with gases, it does figure into the problem. So if you have a problem that says that this gas is at standard temperature is going to be 0 degrees Celsius or 273 Kelvin. So they could either give you the temperature in Celsius or Kelvin. If they give it to you in Celsius, you're going to have to convert it over to Kelvin. And that's a simple conversion. So here, convert 25 degrees Celsius to Kelvin. What we're going to do is take our 25 and we just simply add 273, because 273 Kelvin is equal to 0 degrees Celsius. All right, so we add those two together, and we're going to get 298 Kelvin for our answer here. And vice versa, if it gives you, or you work out a problem and it's, you're trying to find a temperature, if you do get your answer in Kelvin and it wants to know the answer in Celsius, you're going to have to convert from Kelvin to Celsius. So you just take whatever the number is and subtract 273. Okay, and so that's going to give you your answer in Celsius. So 600 minus 273 is going to be 327. So that's 327 degrees Celsius on that conversion. Okay, pressure. Well, let's define what pressure is first. Pressure is the frequency, which means how often, and the force, which means how hard, that the particles collide with the inside of the container. So if you have a container of gas, like you have a compressed air in a tank, the molecules or atoms of air that are inside that can are moving around at a constant, high speed, straight line, fast movement. And when they hit the inside of the container and they bounce off, each one of those that hit and how hard they hit is what determines the pressure of gas in that container. All right, so it's the frequency and the force that the particles collide with the inside of the container that they're in. Standard pressure. Unfortunately, with pressure, there are 5 different units that we're going to be working with. Atmospheres, mmHg, which means millimeters of mercury, Hg. Torr, kPa, which is kilopascals. And then PSI, which is pounds per square inch. Okay, so the standard pressures for each one of those units are listed there, so please write those down. All right, so if you have a problem that you have atmospheres and it asks you to convert that into millimeters of mercury or mmHg, then you're going to have to do that conversion. So let's start off with our given, which is 1.2 atmospheres. Okay, put it over 1. Okay, we're going to get rid of atmospheres and we're going to convert it to millimeters of mercury. All right, so let's look at our qualities here. So we're going from millimeters of mercury to atmospheres. Well, 1 atmosphere is equal to 760 millimeters of mercury. So our atmospheres is going to cancel. And when you do this math, you're going to get your answer in millimeters of mercury. So it's 1.2 times 760, which gives us 9.12 times 10 to the second power. Okay, and that's in millimeters of mercury. All right, so all of these are just simple conversions. So converting 600 torr to kilopascal, start with your given, which is 600 torr, put it over 1. We want to get rid of torr, so we're putting it on the bottom. Kilopascal goes on the top. Okay, so 760 torr is equal to 101.3 kilopascals. So you're going to multiply these two and then divide that whole answer by 760. And so 600 times 101.3 divided by 760 is going to give you 79.9736. All right, and so we have 1 sig fig here. So this is going to be 80. Would be your ultimate answer on that. Okay, on this one above, we have 2 sig figs here. So it would be 9.1. That 2 would drop off. All right, moles Moles is another unit that we're going to be working with. So anytime you have like oxygen here, and you're given a volume of oxygen, 35.6 liters, we're going to need to convert that to moles. All right, so again, this is just a simple conversion. How many moles are in a liter? 22.4 liters is equal to 1 mole. Okay, so that's a conversion factor that we used a few months ago. It's on your mole map that's in your folder. So let's take 35.6 liters of oxygen. Now remember, oxygen is diatomic, so it's O2. Okay. All right, and so we have liters of oxygen, moles of oxygen. Okay. And so we're going to use our conversion factor here. 22.4 liters of oxygen is 1 mole. So liters is going to cancel. 35.6 divided by 22.4 is going to get you your answer. So I'm just showing you how to set these up as a reminder and how to do dimensional analysis or conversions. Okay, here, so we have 35 moles. We're going to put that on top. Okay, convert. Moles goes on bottom, so we can force it to cancel, and we're converting it to liters. Okay, and this is hydrogen gas, so it's H2. Remember, hydrogen is diatomic as well, so it's H2. So 22.4 liters is equal to 1 mole. There's your conversion factor. This time we're multiplying. So when you're going from moles to liters, you multiply. When you're going from liters to moles, you're going to divide. All right, and that's it for the units and for 5.1. So we're going to have some practice on that, a lot of conversions this week. One thing that I do want to tell you is that in this unit on gases, we do have a group project that we're going to be doing. And this group project is to make hot air balloons. And so if you're watching this video and you watch it all the way to the end, then you're going to know to do this. I need you to bring at least 2 packages of tissue paper per group. If you bring tissue paper in tomorrow, and this is for tomorrow only, I'm going to give you 2 power-ups. So 1 power-up for each package of tissue paper that you bring in. Now don't bring in 50 of them because I'm not going to give you 50 power-ups. So the limit is 2. So 2 packages. And when I talk about tissue paper, I'm talking about the tissue paper like this picture here that you use in gift bags. I am not talking about tissue paper that you blow your nose on or tissue paper otherwise called toilet paper. Okay, so we're only talking about the colored tissue paper that you put in gift bags. Bring that in tomorrow and you're going to get a power up for each one up to 2. Okay, so thank you for watching.